Welcome to the video tutorial Java List Collection. With me, Nama Ming from CodeJava.net. You know, list is a fundamental data structure in programming, and in Java, list is a widely used collection type in the Java collections framework. And in this video tutorial, I will help you understand the characteristics of list collections, and you will learn how to use some of list implementations for your day-to-day work with various code examples of common programming practice when using list collections. So, what is a list collection? Basically, a list collection is a kind of data structure that stores elements by insertion order, either at the end of the list or at a specific position in the list, and the elements in the list are accessed by an integer number called index, and index in Java is zero based. That's like array, but unlike array, the capacity of a list is automatically increased when the list is full. So list is more flexible than array, as you can store as many elements as you want in the list without worrying that the list is full. And here's an example of a list collection with 5 elements. The first element at zero index is apple. The second element at one index is lemon, and the third element at index 2, the fourth element at index 3, and the fifth element at index 4. And you can add new elements at the end of the list at a specific position. For example, at index 2. And here are the key characteristics of a list collection. We can store elements of any type in a list collection, and elements are sorted by the insertion order. No elements are allowed, and also duplicate elements are allowed. Let's take a quick look at the API of the list collection in the Java collection framework. You see, this is the class diagram of the list interface, which is defined in the java.ut package. A list is a super interface of all list implementation in a Java collection framework. It defines a common method that allows the programmers to manipulate elements in the list structure, add elements to the list, add over here, read elements from the list, add here, update elements in the list, remove elements from the list, and iterate through the elements in the list using iterator here, and so on. And this is the API inheritance tree of the list collection in the Java collection framework. You see, at the root of the tree is a collection interface, which is a base interface for all collection interfaces in the Java collection framework. And under it is a list interface. And there are 3 key implementation classes of the list interface are ArrayList, Vector, and LinkedList. In the middle between the interface and the classes is the abstract class, abstract list. A linked list is also a kind of queue, so you can see the queue interface here and the queue interface here. And let's understand the 3 implementation classes in the list collection. First, ArrayList is a list collection that is backed by an array, and we use ArrayList for fast and random access of elements because ArrayList provides constant time access to elements, and we use linked list, which is backed by a double linked list for fast adding and removing elements at the end of the list. So you see there are two main differences between ArrayList and linked list. The first one is internal data structure. ArrayList uses array, and linked list uses double linked list data structure. And ArrayList provides fast access to elements, whereas linked list provide fast adding and removing elements at the end. And vector is a legacy collection which was created in the early days of Java. A vector is similar to ArrayList, but it is thread safe. And note that both ArrayList and linked list are not thread safe. That means a vector is safely used in a multi-threaded application. Multiple threads are reading and updating the collection at the same time. But ArrayList and linked list are not safely used in multi-threaded applications. Let's go to the coding part. First, we learn how to create a new list collection in Java. You know, there are several ways to create a new list collection, and the first way, we use the default capacity of the list collection. That means the initial number of elements that the collection can store. For example, this statement create a new list called list fruits. On the left side, you see the type of the list is list interface here, and the parameter type is string. This is a generic type. That means this list can store only elements of type string. And on the right side, we specify the implementation class ArrayList here with an empty constructor. By default, the default capacity of the ArrayList class is 10. That means initially an ArrayList can store 10 elements, and if we add more than 10 elements, then the list can automatically resize, increase the capacity. And to demonstrate the coding part, I use NetBeans IDE 9.0. You see here, it is running under Java 10 OpenJDK, and I will write code inside this list tutorial class in the main method here. Now let's create a list collection that stores elements of type string. We use the interface list from the java.lt package here, and the type parameter is string. List fruit equal new. We use the implementation class ArrayList string. Empty constructor to use the default capacity. And print the content of this list fruit. Okay, and run this file, and you see the content of the list is empty, no elements. Similarly, we can create another collection with the implementation class LinkedList with different type parameter integer. list integer numbers equal new linked list, and print the content of the list numbers. And here fruit. Now run the file. You see, both lists are empty. And if you want to specify a capacity when creating a new list collection, you can specify the number capacity, pass the number to the constructor of the ArrayList class here. You can hold the control key and click mouse to the ArrayList class here to see the source code of the ArrayList class, and you see there's a constructor that has a parameter initial capacity here. You see, and you can see the initial or default capacity of the ArrayList class is 10 elements. Now specify the capacity number for the list first here. When you are sure that the number of elements of the list is around a specific number, you can specify the capacity number when creating the list. For example, I'm sure that this list first will contain around 100 elements, so I specify the capacity is 100 here. Save the file. The benefit of specifying a capacity when creating a list collection is that performance, because you see, when the number of elements added to the list is greater than the default capacity, the list has to increase the size of the internal array, which is a time-consuming operation. You see, the element of the list is stored in this array. And you can see in the add method that put an element to the list here. The list need to row its internal array. So by specifying a capacity, we can gain some improved performance if the list contains more elements than the default capacity. And the linked list class has a default capacity of 0. Hold Control key and click here, and you can see the size of elements in the linked list is 0, and you see it doesn't have any constructor to specify the capacity, because a linked list uses different data structure. It uses double linked list data structure, unlike ArrayList. Okay, so we can specify capacity for ArrayList class only. And from Java 9, you can use a collection factory method list.off to specify some initial elements when creating a new list collection here. So here I can assign this fruit to some initial elements here. List of, you can use a of method, and you see it provides various overloads to accept many elements of, for example, apple, banana, mango, 3 initial elements. Save the file and run. And you see the content of the list fruits had 3 elements: apple, banana, and mango. And note that when you use this factory method of here, the return collection is immutable. That means you can't modify the return collections afterward. Just read only. And from Java 10, you can use the var word here to declare the correction more quickly, more succinct in a local in a method only. So here I can replace var list first. You see, from Java 10 we can use the var keyword here. No, var is a reserved word, not a keyword. So in this statement, the Java compiler can infer the types of the variable here. Similarly, we can use var numbers equal new linked list, and the compiler can infer the type of the variable numbers based on the type on the right side here. So it makes declaring a correction easier, right? Run the program and you see the same result. You see. So that's how to create a new list collection in Java. Next, let's see how to add elements to a list collection. The list interface provides some methods for adding elements to a list collection here. The add method that takes an element, and the second overload add an element at a specified index in the list, and the add all method add elements from another collection to the current collection, and the add all method overload add elements from a collection at a specified index in the current collection. Now let's write the code. Here we add some elements to the linked list numbers here. Numbers using add method 1, 2, 3. Okay, and run this file, and you can see the numbers list now has one element, 1, 2, 3. Now add another element, numbers, add 1, 2, 8, numbers, add 4, 5, 6. Run, and you see it contains 3 elements now. Note that the add method returns a Boolean value indicating that the collection has changed after the operation. If the value is true and if false, that means no element added to the collection. So if necessary, you should check the return value of the add method here. Now delete this code. You see the list fruit is created from the factory method, and as I mentioned before, the return correction of the factory method of is immutable. That means you cannot modify the correction afterwards. So let's try to add element here. For example, lemon, and here we got a runtime error. Hold on. You see, exception in thread main java.lang unsupported operation exception, immutable correction. So it is different from creating a list correction from an implementation class ArrayList. So here I create this list fruit from a new ArrayList with default capacity and add elements to the list. Apple, banana, and now let's run this program, and you see the list fruits has three elements: apple, banana, and lemon. You can see the add method with a single parameter appends the element at the end of the list. And if you want to insert element at a specified position in the list, you can use another overload of the add method that takes an index parameter here. For example, this fruit add at the I want to add a new element at the index 1. For example, apple, banana, lemon, and orange. And let's run this program, and you see orange is inserted at the index 1, 0, 1, 2, 3. And let's test another method add o that put elements from another collection to the current collection. So I create a new collection here, list, string. Sorry, in this declaration with the var keyword, we should specify the parameter type here, so the compiler can infer the type of the corrections. Let's string list fruits to equal new array list. And now you can use add o method to add all elements from another collection. Here I add the elements from the list fruits to list fruits 2. And now let's print the content of list fruit 2. Fruits 2, list fruits 2. Okay. and run this program. And you see list fruits 2 has the same elements as the list fruits, because all elements from list fruits added to the list fruit 2. And if you add another element here, and, for example whether here, run, and you see whether is added to the end of the list. Let's try another overload of the method add_o that adds the elements from another collection to the current collection from the specified index. So now we have the list first with 3 elements here, and now I declare another list collection, list string, list 2, using factory method of orange grep whether. And now I add elements from the list 2 to the list fruits using the add_o method with the index. I add elements from the index 1. Okay. First before and after add_o here. After. Now run this program, and you see before the list fruits there are 3 elements: apple, banana, and lemon. And after add_o method here, we insert 3 elements: orange, grape, and guava. Orange, grape, and guava from the index 1. You see, and that's how to add elements to a list collection. You can see the benefit of using a list is that you can add as many elements as you want, and the size of the list is automatically increased when needed, unlike array, which has a fixed length. Now let's see how to get elements from a list. And you see the list interface provides a method get that allows programmers to retrieve an element from the list at a specified index. Now let's write the code. Delete here. List fruit red. Specify the index. For example, I want to get element at index 1, and assign the return value to a new variable 1 fruit, and print 1 fruit. Run, and you see it displays banana, which is the element at the index 1 in the list. If you specify the index number greater than the size as a total number of elements in the list, we write an exception. For example, I specify the index 10 here, but this list contains only 3 elements, so we will get an exception. You see, index outbound exception, index 10 outbound for line 3. So be careful when using the red method, which you should check the index uh, against the size of the list. For example, if list fruits size, you can use the size method greater than 10, then you get the element at the 10th index. You see. So when using the get method, you should check the size and check the index to avoid the index outbound exception. Okay. You know, the greatest benefit of using a list collection is that it provides constant time access to elements in the collection by index. That means whether the element is at the first, at the beginning, or at the end of the list, the time to get the element is the same, and we prefer using a list when we want to have fast access to elements by index. Now, based on index, we can get the first element, which is always at the 0 index. Change the name to first element, and last element, list fruits red. You can always get the last element as the index equal to the size of the list minus 1. First and last. Now run this program. You see, the first element is apple, and the last one is lemon. You see. Now try to add another element here. Strawberry. Run. And you see, the last element is now strawberry. Now change the implementation class to LinkedList. LinkedList. Okay. Run the code and you see the same result. First element apple and last is strawberry. But the LinkedList class provide another method to get the first element and an element. You see, get first. This method is specific to linked list only. It doesn't have in the list interface. And to get the last element, you see, this is a method from the linked list in which uses double linked list data structure. Run the program and you see the same result. You see, first element is apple and the last one is strawberry. To update or replace an element, in a list collection, we can use a set method here with two parameters. The first parameter is the index, the position of the element, and the second parameter is element. And this method returns the previous element in the collection if the operation succeeded. Here, delete this code before and after. And now I want to update the third element here. List fruits, set third element at index 2, and the new element, the place is the one is mango. Now run this program. You see, before you see the element at the second index, the third element in the list is lemon, and after the set method is invoked, the element at the second index is updated to mango. You see, if you specify the index here is less than or greater than the size, less than 0 and greater than the size of the list, you got an exception. For example, if you use index -2 here and run the file, we got array index about exception here because the index is less than 0, and if the index is greater than the size of the list, we also get the index about exception. Let's run this file. You see, so when using methods that have parameter of index, you need to check the index very carefully to avoid the index out exception. To remove elements from a list collection, the list interface defines the following methods. Remove with two overloads. The first one removes an element from a specified index, and the second method removes an element from object, and the remove all method here removes all elements contained in the specified collection, and the clear method remove all elements from the collection. Now let's test the first remove method. Change declaration to list interface chain and implementation class to ArrayList. Here I removed the element at the third index, which is strawberry here. Now let's run this program. You see, before we had strawberry at the end, and after the last element was removed. And we can also use a remove method that takes an object as a argument. Here I can remove the banana. Now let's run the program. You see, a banana was removed from the list. And note that when using the Second, overload remove with object as a parameter. The class of the object must implement the equals and has code method so the collection can find the object. And now let's test the remove all method that removes all elements that are contained in the specified collection. So we create another list collection here. List string list names equal new. You can use factor method list of to create a list with some initial elements: Apple, Google, Oracle, for example. And now we use a remove all method on the list first. Remove all elements that are also contained in the list name here. Now run the program, and you see, because there's only one element Apple that is contained in the list name, so it is removed from the list fruits you see here. And let's test the clear all method. Clear method that removes all elements from the list. Now run the program. And you see, before we have 4 elements, and after that the list is empty. Note that the remove and remove all methods return values, so you can check the return value to make sure that the elements are actually removed from the collection. And to iterate through the elements in a list collection, we can use the following methods. Use classic for loop, use for each loop, use an iterator, and use for each method available in Java 8. Now let's see how to use a classic for loop to iterate through the elements in the list first here. So delete this code. For in the classic for loop, we use a counter variable here. Integer I equals 0, which is index of the first element in the list, and I less than the size of the list. And for each loop, we increase the value of I by 1. And then we use the get method to get the element as the specified index by the I variable here. String. Assign the return value to a string because the type of the collection is string. String fruit equal, and print the element fruit. Now let's run this program. You see, it prints apple, banana, lemon, and strawberry. And to iterate through the elements in this collection using a for each statement. Yeah, for each string element fruit in the collection list of fruits. You can print the fruit name. Fruit. You see, with for each statement, we write less code and it is more readable. For each string fruit in the list fruit collection, we print the fruit. Let's run this program to see. You see, same result. But apple, banana, lemon, and strawberry. And the third way, we can use an iterator. We obtain an iterator from the list fruits iterator. Assign return value to new variable. You can see the list interface defines an iterator method that returns an iterator that allows us to iterate through the elements in the list. Here we can iterate through the elements using iterator like this. Why? Iterator has next. If the iterator has next elements, we get the next element from the iterator next and print it out. Fruit. Now run this program and you can see the same result. And the fourth way to iterate through elements in a list collection is using the for each method introduced in Sin Java 8 with lambda expression. So I delete this code and list fruits for each. And you can use a lambda expression. For example, fruit test out fruit. Okay, let's run this program. And you see the same result. And you see with the for each method, the code is more succinct, and even you can just use method reference here. System dot current print light. You see the short form, and you run this program and we have the same result. So I have show you the 4 ways to iterating through elements in a list collection. Next, to search for an element in a list collection, the list interface provides following methods: contains index of and last index of. And note that the class of the object used in the argument here must override the equals and hash code methods, so the collection can search for the object. The contains method return true if the collection contains the specified object O here. And let's test this method first. For you see, for the type parameter the string class already implements the equals and hash code, so we can safely use this method with string. So I delete here and list fruit contains. I check if this list contains an orange. this method contains returns true or false, so we can use the if statement to check the return value here. The list contains an orange, else no orange file. And now let's run this program. You see, it prints no orange file because you see there's no element with the string orange in the list. Now let's add orange here and run the program again. And you see, it prints the list contains an orange. That means the contents method here return true. If you use another object type other than the type parameter declared in the list collection, this method contains will return false. For example, contains a new integer 1, 10. For example, check a number. Okay, this number 1 will be converted to a wrapper type integer. Now run this program, you see no orange file. You see, because the type of the object here is different than the type of the object in the list, which is string. The next method, index of, returns the index of the specified object. Now let's test it. Index equal list fruit index of. We check for the index of the lemon. And print the value of the index. Now let's run this program. And you see it prints 2 because the lemon element here is at the index 2, 1, 2, 3 in the list. Now let's try to check the index of pineapple. Run the program and you see it returns -1 because no pineapple in the list. When this method index of returns a negative value, that means the object could not be found, not present in the list. And the last index of method returns the last index of the specified object in case the list contains more than instance of the object. For example, because the list allows duplicate elements, so I can add another apple here. And if I run the method index of, it will return the index 0. You see here because the first apple at the index 0. And now let's use the last index of method here, and it will return the index of this apple. Run 5, and you see the index is 5. 0, 1, 2, 3, 4, 5. And to sort elements in a list collection, we can use static methods of the utility class collections. The sort method that has a parameter is a list collection, or the second method that has two parameters, list collection and a comparator. And since Java 8, we can use a shorter way, call the sort method directly on the list collection. Now let's write code. Now I add more elements to this list collection. However, okay. And print the content of the list collection before and after sorting. Before list fruits and after. Now we can use collection utility class collections. Its sort method sort list fruits, and by default we sort the elements in the list by their natural ordering. For the string elements, the natural ordering of the string element is alphabetic order. Now let's run this program to see. And you can see before the content of the collection here, and after that it is sorted apple, banana, guava, lemon, orange, strawberry, because in this list collection we had 2 apples. Note that the class of elements in the list must implement the comparable interface. So the elements in the list collection can be compared to each other. Otherwise, if we get an exception. In our case, since the type parameter of the list is string, the string class implements the comparable interface. So the sort method of the collections class can sort the list of string. Click here to see the string class, and we see the string class implements the comparable interface here. Now let's try to create a custom type and create a collection that stores a custom type. For example, I create a new type person here. The person has name, and age. We generate constructor. The constructor that takes 2 parameters, name and age, and generate a getter and setter. Encapsulate views, cycle, refactor. Okay, we see a very simple custom type person. Now create a new class list tutorial 2. We create a main method, public state, and here we create a collection that stores only elements of type person. List person. This person equal new ArrayList. And now we add some person to the list. Add new person. Adam, 25 years old, and the second person is John, 34. Okay. Now let's print the content of the list of persons. Run this program, and you see where is change output with the fully qualified class name with some numbers here, because the person class doesn't override the toString method, so we need to override the toString method to the system out print line can print the meaningful content of each element in the list persons. Insert code to G. We use just the name of the person in the toString method. Yeah, we just return name of the person. Now run this program again, and you will see now the content of the list Adam and John. Now let's try to use a collections method sort this person. And you will see a compiler error here, because the list person is of type person, which doesn't implement the comparable interface, so the Java compiler doesn't allow the code to be compiled. And you see, now we need to make the class implement the comparable interface to compare two element comparable person. And implement the abstract method compare to. Yeah. This compare to method is called by the list collection when we call by the sort method of the collection class when we sort the list elements to compare the elements of the list. As a person. So here we compare the name of the person. Okay. Return another this name compared to another person. Get name. So this method means that the person elements in a list collection will be sorted by the person name. Now let's add another person to this list. Here we add Carol 19 and David 41. You see the error has gone because the person class now implements the comparable interface on this program. We print before and after. Run this program, and you see the list person is sorted for Adam, John, Carol, and David, and after Adam, Carol, David, and John. The compare to method defines the natural ordering of the elements of the class in a collection. And if you want to sort the list in an order which is different than the natural ordering, you can use the overload sort method here with two parameters, collection and a comparator. Now let's see. We want to sort this list fruits in descending order of the alphabetic order. So we call the sort method with comparator here. We can use an create abstract and anonymous class here. New comparator string. Implement the compare to method of the comparator interface. Click here and you can see this is an interface comparator that has the compare method here. Now in the compare method we return an integer value. If greater than 0, then the first element is greater than the second element, and if the return value is less than 0, the second element is greater than the first element. So here I compare in the reverse order, so I return the second element S2 and S1, S2 compared to S1 in reverse order. Now run this program, and you see after the elements, string elements in the collection are sorted in a descending order of the alphabetic: strawberry, orange, lemon, guava, banana, apple, and apple. So that's how to use the overload of the sort method with a comparator. Another example, if you want to sort the list of person by the age of the person, so you can use a comparator here, new comparator person. This is an anonymous class that implements the comparator interface and overrides the compare to method. Here we compare the person 1 and person 2, the age of the person. Return P1 get age, because the value of the age is an integer primitive type, so we must use a minus operator here, P2 get age, to compare. Now let's run this program. Now you can see after the list person is sorted, the person elements in the list order in the ascending order of the age. You see Carol, who is 19, is first, Adam 25 next, John 34 next, and the last one is David, who is the oldest person, 41. You see. And from Java 8, you can use a sort method directly on the list collection instead of using the collections utility class. So here we can modify list person, call the sort method directly. And pass the comparator to the method here. Run this program and now update the toString method of the person class to print the name, the h next to the name. This dot h, and now let's run this program and you will see Carol 19, Adam 25, John 34, David 41. So the list is sorted by the age of the persons. And if you specify no as a value for the sort method, the collection will be, the elements in the collection will be sorted in natural ordering. Save the file and run this program again. And you see now the list is sorted by the name of the person, which is a natural ordering: Adam, Carol, David, and John. To copy elements from one list to another, we can use the copy method of the collections utility class here. That takes two parameters. The first parameter is a destination list, and the second parameter is a source list. Now let's see how to write the code. Delete the code to sort the collection here, and now I create another, the second collection. List string list fruit 2 equal list of this list collection contains some elements like watermelon, blackberry, and cherry. Now we copy the elements from the list fruit 2 to the list fruit collections. Copy this fruit 2. Okay. Now let's run this program. You see, the list fruit 2 has 3 elements, and it when after copying the first 3 elements of the list fruit, the first list are replaced by the elements in the source list. You see here. So by copying elements from the source list to the destination, the elements in the source list is replaced by the elements in the same index of the source list. The elements in the destination list are replaced by the elements at the same index of the source list. Now let's delete some lines here to make the list fruit has only two elements. And now let's run this program, and we see an exception index exception. Source does not fit index, so when using the copy method here, the number of elements in the destination list must be equal or greater than the number of elements, the size of the source list. Otherwise, we will get the index outbound exception. To shuffle the elements in a list collection, we can use the shuffle method of the collections utility class. This shuffle method randomly permutes the elements in the list here. Now let's see how to use this method and the result. The list 2. Now I shuffle the element in the list fruit shuffle list fruit and run the program. You see, after the order of the elements in the list is unspecified, they are ordered in a random. Orange, banana, strawberry, apple, lemon, guava, apple. And let's try to shuffle this list person. Collections. Shuffle. Run this program. And you see, after that, we have Carol, Adam, John, David, which is in no specified order. So you can use the shuffle method of the collections class to randomly permute the elements in a list collection. And to reverse the order of the elements in a list collection, we can use the reverse method of the collections class here. Now let's reverse the elements in the order of the elements in the list fruits here. Reverse. Run this program and you will see. After that, guava, apple, orange, strawberry, lemon, banana, apple in the reverse order. You see. And let's try to reverse the order of the persons in the list persons. Reverse. Run the program. And you see. Before Adam, John, Carol, David, and after David, Carol, John, Adam, exactly in reverse order. So you can use the reverse method to reverse the order of the elements in a list collection. To get a portion or a small set of elements from a list collection, we can use the sublist method with two parameters. The first is from index inclusively, and the second parameter is to index exclusively. Now let's see how to use this method. I want to add only a sublist from the list first here. List string some fruits equal list fruits sublist from the first element at index 0 to the fourth to the third element to the third element at the index 2 here. So the second parameter I specified 3. You know the first index is inclusive and the 2 index is exclusive. So this return a list of string with 1, 2, and 3 elements. Now, after print the content of the sample collection, run this program and you will see apple, banana, and lemon are the 3 elements extracted from the list fruits. Now you can change from index here to from the index 3 to the index 5, index 0, 1, 2, 3 from strawberry to 5, index 5, 5. So this sublist returns only one element, strawberry. Now let's see. Run. Oh, sorry. Index 0, 1, 2, 3, 4, 5. So it has 2 elements from the list fruit, strawberry and orange. And that's how to use a sublist method to get a small set of elements from a list collection. We can convert from list to array and vice versa, from array to list. From arrays to list, you can use a static method of the arrays class as list with a specified array, and it returns the list collection which is immutable. That means using list this method, the return collection cannot be modified afterward. Now let's see how to use this method. Now I declare a list. Let's delete this. Convert from array to list. I declare an array of string here. First, with some elements here. Watermelon, cherry, papaya, for example. And now to convert this array of string to a list of string. List string, list first to equal arrays as a list fruits. You see. Now print the content of the list fruit 2. Run this program and you see watermelon, cherry, and papaya. Note that the return list collection from the asList method is immutable. That means you cannot add or remove elements with this list. For example, I try to add more elements to this list. For example, blackberry here, and run this program, and we will get an exception. You see, java.lang not unsupported operation exception. That means the return list from the ArrayList method is immutable. And to convert from list to array, we can use the toArray method with no parameter that returns an array of objects, or use the toArray method with a parameter to return an array of a specified type. Now let's see. I convert the list fruit here to an array. Array of string fruit equal list fruit to array. New string with a 0 element here. And you can check by print the size of the array length. Run this program and it should print 1, 2, 3, 4, 5, 6, 7. Run. You see it prints 7. Now let's iterate through elements in this array. For string fruit in fruit, print the fruit. Run this program and it should print exactly the elements that appear here in the list fruit collection. You see apple, banana, lemon, strawberry, orange, apple, and guava. And that's how to use the toArray method to convert a list to an array. From Java 8, we can convert a list to a scheme to use the scheme API to perform various operations on elements of the scheme. And the scheme method returns a sequence scheme. The parallel scheme method returns a parallel scheme from the list collection. And now let's write some code to use a scheme from a list collection. For a better demonstration, I declare a new list of type integer number. List integer numbers equal list of, we have some number elements here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And numbers dot scheme to return a sequential scheme, so you can use the operation on the scheme. For example, here I apply the filter function. I apply filter using a lambda expression. I filter only the numbers that are even numbers. So even number is here, okay. And print the even number system. Not how. No. This is the lambda expression. Now let's run this program and we see it will print only the even numbers. 2, 4, 6, 8. Run. You see, 2, 4, 6, 8. Very convenient, right? Or you can calculate the sum of the even number sum. Count. So you can count the number of even numbers in the stream. Number of even numbers. For example, this didn't long. I run this program and you see 4 numbers. 1, 2, 3, 4. So that's how to get a stream from the list collection and perform operation on the stream. By default, list implementation like ArrayList and LinkedList are not thread safe, except the vector class is a legacy collection which is thread safe. So to use ArrayList and LinkedList in multi-threaded application, you should use a synchronized list method of the collection class to create a thread safe collection, wrapping the list collection here. Let's see. For example, here the list persons. This list person is not thread safe, and now I want to add a list collection which is thread safe, can be used in multi-threaded applications. List person save list person equal collection synchronize list person, and then you can use the save list person here. This is the wrapper of the unsaved list persons here. You can use this, return synchronized list collection in a multi-threaded program. And that's the tutorial about list collection in Java. I hope you found this video tutorial helpful, and thank you for watching.